Intermediate Algebra, Section 9.4. If we know the logarithms of two different numbers with the same bases, the properties allow us to calculate other logarithms. So in this example, we're given log base b of 4 has a certain value, log base b of 12 has another specific value, and they're asking us to find log base b of 3. We want to transform 3 into these numbers so that we can calculate a value. And it turns out if you have 12 divided by 4, we can come up with 3. So an equivalent expression for b, log base b of 3, would be log base b of 12 over 4, this quotient, since 12 divided by 4 is 3. By transforming it into these logarithms that we actually know a value of, we can use our quotient property of logarithms, which says if you have a quotient, it's the same as the difference of the numerator minus the denominator. Once we've broken it down in this form, we then can replace log base b of 12 with the given value 1.387. Likewise, log base b of 4 has a value 0.744, and the only thing left for us to do then is to subtract these two numbers and gives us a value 0.0643 for the solution. In the next one, we have log base b of 16 that we want to transform to come up with a solution. Well, 16 is 4 to the second power, so an equivalent logarithm would be 4 to the second power for our log base b of 16, since 4 to the second power is 16. Using our power rule, the exponent becomes the coefficient, log base b of 4, and using substitution, we can replace now that we have log base b of 4 with the value that was given, 0.744, and multiply to give us our solution. And when we multiply those two numbers, we end up with a value of 1.488. In this last example, we have log base b of 10. And as it turns out, 10 is 2 times 5. There's nothing else that we can do with the 4 and the 12 that were given to manipulate these numbers to give us a 10. And so for this example, with those two specific values, we cannot find the value. Cannot be found. In this next set of problems, they're asking us to simplify the following, and we can go back to some of our properties that we haven't used. If we have our list nearby, the logarithm of a base to an exponent has the following form that we're looking at in this particular problem. So looking at that, since we have the base of a base raised to a power, it appears according to the logarithm of a base to an exponent, the answer is 5. We can use that, or we can rely on setting it equal to an unknown and translating our logarithmic form into an exponential form. That's equivalent, which would be the base to that value is equal to what we're taking the logarithm of, and then using our principles of exponential equality, if you have common bases, exponents must be equal, so x is equal to 5. So we have two ways that we can get there, either using the logarithm of a base to an exponent, base, your exponent is your solution, or translating it into exponential form. So looking at this next one, has the same form. Let me slide that down so you can see the previous one. We're taking log of a base of a quantity that's the same raised to a power is going to equal that power. And whether you translate it or using that formula or property that we have for logarithm of a base to come up with your solution.